Hi everyone, it's Miss Mayorga, and today we're going to be going over lesson 19 in code.org unit 3. So as you might see, I am outside recording today. If hopefully it doesn't get too loud. If it gets too loud, then I will move inside, but it's nice out, so I figured I'd come out here. You might hear cars go by back and forth, but hopefully it doesn't get too loud. Anywho, lesson 19, collision detection. So we're finally getting into some more exciting stuff, which is detecting collisions. So let's take a look. Essential question. How can programming help make complicated problems more simple? And then our learning objectives are detect when sprites are touching or overlapping and change the program in response. Describe how abstractions help to manage the complexity of code. Today's lesson will go over bubbles 1 through 8. Bubble 7 will complete both activities, and bubble 8 will be graded. So I'll get you started on that, but I won't show you how to finish it. Here you have the blocks that we're going to be learning today. And just some reminders and a little sneak peek into what you should be able to do after today's lesson, if it plays, maybe. Boom, right, collision detection, and then a response to the collision. All right, let's get started. Code.org, make sure you're signed in, and we are doing lesson 19. I'm going to go straight to bubble 2. Bubble 1 is just the overview, so going straight to bubble 2. Dinner time. Run the program to see the robot bring the bunny dinner. When the bunny reaches the bowl, they both stop walking and the bowl becomes empty. What code do you think would help the computer know if two sprites were touching? So go ahead and run the program. Boom. So we see that when the bunny touches the bowl, everything stops and the bowl becomes empty. What information do you think that the computer might need to know or might look at to determine if two sprites are touching? Yeah, so maybe you thought about position, X position, specifically X position, but position, right, coordinates. The computer needs to be able to compare, draw some comparison between the coordinates to know, are they touching? Let's go ahead and check out the code behind the scene. Go ahead and click continue, and moving on to bubble 3. All right, using math to figure it out. Computers use math to figure out whether sorry, it's a little windy. Computers use math to figure out whether two things are touching. Look at the math on lines 17 through 18 of this program to see how the sprite properties are compared with their width to see whether they are touching. All right, so let's see what's going on here. Read the if statement inside the draw loop and find the different sprite properties and how they are compared. Discuss the code with your partner, with the class, with me, with yourself. Why does the code only use the width and X properties and not the height and Y properties? Would you want to write this code every time you checked whether something is touching? All right, let's take a look. Here is the code behind the scenes. These two very long lines look super complicated, but as you can see, a lot of the things that the computer is looking at is the X property of the sprites. Bunny.x greater than bunny dinner.x. Looking at the difference between the sprites, if that's less than the sum of the widths. We also have bunny.x less than dinner.x, and the difference between the positions is greater than the sum of the widths, the negative of the sum of the widths, right? There are a lot of things that are within each other, right? With math within math within math, right? And it looks very complicated. So if you don't fully understand what's going on here, don't worry, because you're in luck. There's already a block that is going to do all this math for us. But this is just to show you what's going on behind the scenes. So you obviously probably wouldn't want to write this code every single time you had to check if something was touching. And luckily you don't have to, right? So here you can answer those questions if you want to. I did not require you to answer those questions. I just say enter a space, run the program. It's the same program. Go ahead and click finish. Moving on to bubble 4. Okay, so now we're going to code the same program, but in a much simpler way. Writing out the math each time you want to check whether two sprites are touching can take a while. So a programmer created the isTouching block, which can check whether one sprite is touching another sprite, the target. The computer is still doing the same math as in the previous program, but you don't have to worry about it because another programmer already did that work. So do this. Inside the draw loop, drag the isTouching block into the if block. Hint, don't forget to change the sprite to bunny and target to dinner. So let's go ahead and go into our code. Here is our if statement. inside here, we're going to drag the sprite isTouching block. This is the block of code that's going to ask the computer to check, hey, are these two sprites touching? So we need to tell the computer which sprites we're looking for. We are looking for, let's read the instructions, when the bunny is touching dinner. Dinner is the target. So we're looking for the bunny sprite. Hold on, there we go. Bunny sprite touching dinner. Right, that's the name of the sprites, bunny, dinner. And that's all we need to do. And now the computer is doing the math for us, right? The block of code underneath, there's all that math, but we don't have to worry about that. Run the program, and it works the same way, but much simpler. Right? Moving on to bubble 5. Applesauce. The blender should only turn on when the apple touches it. Use the new code you have learned to check whether the blender is touching the apple. Use a conditional to only shake the blender when the apple is touching it. All right, so hint, you will need to drag 2 blocks into the workspace. So let's see what's going on. We have a blender. It's already shaking, right? Which line of code, before we get started, which line of code is causing the blender to shake? Which line of code is shaking the blender? Hopefully you said line 10, right? Blender.x gets 200 plus or minus, plus random number, minus 5 to 5. So it's taking the x position and it's increasing it or decreasing it just a little bit. That's what's causing it to shake. Now we only want that to happen if the apple is touching the blender. So what blocks do we need? We need an if statement, right? We need a condition. We're checking a condition. I'm going to put this here under line 9. And we're checking if the apple is touching blender. So we need the isTouching block. Grab that. That's our condition that we're checking. And we need to change the names, right? We need to check for apple is touching blender. Those are the names of the sprites here. If that is true, then we want the blender to shake. Luckily, that line of code already exists here, so all we need to do is click and drag that block into our if statement. And now the computer is going to check, is the apple touching the blender? And when that becomes true, then the blender will shake. Run your program. There goes the apple, and then it shakes, and then it stops shaking. So again, you can follow the apple, and you'll see, if you look really closely at the bottom of the blender, you'll see that the apple kind of goes through it, actually falls out of the blender. It doesn't just stay in there. It just keeps going down. So if you want to make it a little more realistic and you want the apple to just kind of disappear when it hits the blender, so it looks like it fell into the blender, you can use this block here, which is called the visible block. All right, so this is the visibility. You drag it into your if statement, change the name for apple, right? Apple. And this block can only have 2 values, true or false. True means that the sprite is going to be visible. False is going to mean that the sprite is not visible, right? It's false. So go ahead and set it to false. And what will happen now is when the apple touches the blender will shake, but then the visibility of the apple will become false. So the apple, we won't be able to see the apple anymore. So run the program, there goes the apple, bam, and then it just disappears. So it doesn't fall out of the blender in the end, right? It just disappears. Boop, the apple is no longer visible. So it looks like it's going into the blender. You can do it either way. You don't need this visibility block. You can keep it like that, or you can keep the visibility block. Go ahead and click finish. Moving on to bubble 6. Debugging collisions. The balloon is popping before the tack touches it. You can use a debug block to get more information about the bug in the program. Run the code and use the arrow keys to move the tack to pop the balloon. In the code below, okay, let's do that first. Run the code, use the arrow keys. Okay, let's go ahead and pop the balloon. Here's our tack, here's the balloon. Go ahead and use your arrow keys. Pop your balloon, pop. All right, see if you can get close to the balloon. What's the closest you can get? All right, I'm not getting very close. Nope, I can't get very close. So let's see what's going on. In the code below, change the balloon.debug equals false or gets false to balloon.debug gets true. Add a new debug block to the code and set the tack sprite's debug property to true. Run the code again, then discuss with the class, with me, with yourself, why the balloon is popping here. Okay. Line 3, balloon.debug gets false. Let's go ahead and change that to true. And we need another debug block for the tack. So go ahead and grab the other sprite.debug block, put it underneath line 6. Don't forget to change the name, tack, and that should also be true. Now let's run the program again. And what do you notice? What do you notice? There are some rectangles that we see. All right, go ahead and try to pop the balloon again. Pop the balloon. Boop. I'm going to try it again just to make sure. Boop. Now, what do you notice? When is the balloon popping? When is the balloon popping? Yeah, it's popping. Hopefully you said, I'm imagining that you said, when the green rectangles touch, right? So think about these green rectangles as boundaries. So when the computer is looking for a collision, when it's trying to detect collision, it's basing it off the boundaries. So when the boundaries of your sprite touch, that's when the computer's like, oh, there's a collision. However, we have an issue here. The boundary for the balloon, it's really far out. So even though the balloon is further in its boundary, it's got a lot of space. So it's popping early. And we can actually fix that. I know the code didn't ask you to fix it, but I'll show you how to fix it. It's super easy, super quick. So to fix that, go over into your animation tab. Just right up here, animation tab. As you can see, there's a lot of gray space around the balloon. For the tack, there is gray space, but like the tack is taking up as much of the space as possible, right? It hits the side over here, up here, and the corner down here. The pop animation also hits as much of the sides as possible. It's taking up as much space as possible. So we need to crop this. And to do this, you go over to the right side, look at these buttons down here, and then click on this option here, crop the sprite. Just click on it once, and it's going to crop everything out for you. And that's it. Go back to your code, and you can run your program again, and you can see that the rectangle is tighter around the sprite. And now we can pop our balloon and make it look a little more realistic. Pop. Right. If you don't want these green boundaries, like if you don't want to see the boundaries anymore, you can always change these back to false, or you can simply delete those lines. All right, but this is just to show you what was going on. Go ahead and click finish, continuing on to the next one. Okay, so I'm actually going to pause the video here because I'm going to run out of time really soon, so I don't want to just stop in the middle of one of these activities. But I will pick up on Bubble 7, activity A and B, in the next one. All right, see you in part 2.